Good morning, our viewers, our visitors, and once again, Regional Science Center Bhopal is back with another educational program. On this particular day, we are organizing very important event on upcoming celestial event which we call the Great Conjunction of Jupiter and Saturn. So that will take place on 21st December. Before that, today we have with us Dr. Throop from NASA headquarters, and we are lucky to have him in advance before even NASA's live event, which is scheduled on 17 as per their local time. So without further ado, we would like to brief about our science center. This Regional Science Center Bhopal is doing science communication and is popular. Good morning, our viewers. Our visitors, and once again, Regional Science Center Bhopal is back with another educational program. On this particular day, we are organizing very important event on upcoming celestial event which we call the Great Conjunction of Jupiter and Saturn. So that will take place on 21st December. Before that, today we have with us Dr. Throop from NASA headquarters, and we are lucky to have him in advance before even NASA's live event, which is scheduled on 17 as per their local time. So without further ado, we would like to brief about our science center. This Regional Science Center Bhopal is doing science communication and its popularization, is taking science to the masses, general public, school students, and to the doorsteps. Those people are not coming to the science centers through various schemes, exhibitions, mobile science exhibition, and we are also conducting lots of educational programs for teachers. In these particular difficult times, we have been using online platforms in Madhya Pradesh, in the state of Madhya Pradesh, which is the central India, we can say. And on this particular note, we have been organizing many educational lectures, talks by various experts in the past, and today for this upcoming event we have with us Dr. Throop. Good morning, Dr. Throop from India.
Good morning.
Yeah,
Good
Dr.
morning.
Throop is an astronomer at NASA headquarters in Washington, DC, where he manages NASA's scientific research programs in the outer solar system. Throop's research focuses on outer solar system, and he has published over 40 articles in scientific journals on topics ranging from rings of Saturn and Jupiter. And I will quote here, rings of Saturn and Jupiter. And I am going to tell you once again, today we are going to discuss these two celestial objects, and he will enlighten us about the conjunction. And to planet and star forming reasons, to astrobiology and the origin of lives, to searching for Pluto's smallest moon, Styx, in 2012. Throop is a member of the science team for NASA's New Horizons mission, which was first NASA's mission exclusively for Pluto, and he was also involved in this research team. He was involved in the historic encounters with Pluto in 2015 and also MU69 in 2019. He received PhD in planetary science from University of Colorado in 2000. Throop has spent much of his career bringing astronomy to the developing world. While living for 8 years in Africa, India and Mexico, he worked extensively with the schools and community groups, helping to develop their science programs and to inspire the next generation of leaders. He has presented more than 150 lectures for science festivals, planetariums, school groups, and public events across the world. Throop's work has been featured in Science, the renowned science magazine and science journal, Nature, another scientific journal, Time magazine, the Washington Post, on the History Channel and National Geographic TV, as well as dozens of newspapers from Pakistan to Hungary to Namibia and many places. He has this particular knack of public speaking. Throop's work has won him broad accolades, including in 2017 he was awarded both the US State Department's Avis Bohelm Award and the American Astronomical Society's Carl Sagan Medal for his work in science communication and outreach to the public. Asteroid 193736. I will repeat once again. Asteroid 193736, Henry Throop, was named in his honor. Thank you, Dr. Throop, for joining us directly from your place. And in India, from today, our local weather is much clear in comparison to previous few days. And we are hoping that on 21st, we will definitely going to organize this live streaming for our visitors. So now the stage is yours. You can talk about the very important topic, the great conjunction of Jupiter and Saturn.
Thank you, Saket. I will share my screen. Do you see my opening slide here? Okay. Do you see my opening slide here, Saket?
Yes, yes. Go ahead.
Okay. Thank you, thank you. Thank you, everybody, for having me here. Thank you, Saket, in particular, for having me. It's such a pleasure to be back in India talking. I lived for 3 years in Bombay and had such a pleasure in the country, traveling around the country and talking about astronomy, talking about exploring the world around us from all different parts of India, from the south, from the north, from every section of India. And I'm very grateful to Saket, who hosted me at the Nehru Science Center in Bombay, and I'm very grateful for all of you for coming to this
Dr. Henry Throop, I would like to say, I'm just incidental. The institution matters, and our council has 25 science centers across India. So we, with team, organize these events for the public. I may be contacting you or in touch with you, but this is big team efforts, and we all are working for the cause, for the same cause. Please carry on.
I'm so grateful for all of your team and all of the people involved in this to make this possible, and I appreciate every single one of them. So thank you so much, all of you. I'd like to talk today. I'm going to talk for about 10 or 15 minutes about the conjunction of Jupiter and Saturn. And so before I talk about exactly what we're going to see in the sky, I'm going to talk about our galaxy and what we see. And so this is a picture of the Milky Way galaxy, or this is a picture of a galaxy in the universe. The universe is everything, and the galaxies are the spiral-shaped things that we see. Now, this galaxy has 100 billion stars in it. And the Milky Way is the sun is just one of these stars. This is not the Milky Way galaxy. This is someone else's galaxy. We live in the Milky Way galaxy. The sun is just one star in this galaxy. So if we zoom into this star, we see our sun at the center. This is just a cartoon here. Now the solar system, solar means soul means sun, and so the sun is the center. Going around it, we have 4 planets. We have Mercury, Venus, Earth, and Mars going around the sun. And these we call the rocky planets, and that's because they're all made of rocks. These are heavy planets that you can walk on. They're very solid, and they are more or less like the Earth. So if you go to Mars, you could walk around on Mars. If you go to Mercury, you could walk around on Mercury. The sun is at the center, and the sun produces almost all the energy in the solar system. For instance, all of the heat and all of the light in the solar system essentially comes from the sun. So if you turn off the sun, all the other planets would go cold and would go dark. Now, beyond the rocky planets, we have the first large planet that we have, the first giant planet is Jupiter. Here's a picture of Jupiter taken by one of NASA's spacecraft. Jupiter is just made of gas. So it's hydrogen gas and helium gas predominantly, plus other gases, ammonia gas and methane gas and so forth. And you might think, oh, if it's only gas, how does it stay together? And that's because of gravity. Gravity keeps everything together. And so if you have a cloud of gas that's in space, gravity will still cause that cloud to contract together. After Jupiter, we have Saturn. Saturn is slightly smaller than Jupiter, but it's also made of hydrogen and helium gas and the other gases. Saturn has the giant ring system going around it, which is its most famous aspect. Out beyond Saturn, we have Uranus, which is tilted on its side. You can see the other planets are slightly tilted on their side as well. And then we have Neptune out beyond Uranus. Neptune and Uranus are also made of gas. They also have some water in them and some rocks at the center, but they're predominantly gas, just like Jupiter and Saturn by mass. Now, this is not the end of the solar system. Out beyond, this is the end of the gas giant planets. So we have these 4 planets here, which we classify together as the gas giant planets. Also, this is not the end of the solar system. Out beyond Neptune, we have our friend Pluto. Pluto is the smallest of the planets. Some people call it a dwarf planet. Some people call it one of the planets. Either one is okay. And what's critical about Pluto is that it's made of ice. And so as you get further and further away from the sun, things get colder and colder. And that's because all the energy is coming from the sun. So as you get further from the sun, then you have less energy and less heat, so lower temperature on your planet. And so in fact, if you take the room that you are in right now, the air that you are breathing is made of, well, what's in that air? It's nitrogen gas, it's oxygen, it's carbon dioxide, it's methane, and so forth, things like this. And if you take all of those gases and you put them at the temperature that it would be at Pluto, which is about negative 200 degrees, negative 250 degrees Celsius, then which is about 50 degrees above absolute zero. If you take those gases and take them at this low temperature, all of them would freeze into snow and ice on the ground. All of the gases in the room that you are in right now would freeze into snow and ice. And that's how cold it is on Pluto. And that's because it's far from the sun. Pluto is not the outer edge of the solar system. If you keep going, you keep getting to more bodies in what we call the Kuiper belt. And the Kuiper belt is a cloud of small bodies, which are similar to Pluto, but smaller, most of them, which continues outward. Of course, if you leave the solar system, you get to the next solar system. But what I've shown here is about the inner 1% of our solar system. The solar system continues for a vast distance before we get beyond and into the next solar system. So everything we're going to talk about is inside our solar system. We're not talking today about other stars, other galaxies, anything like that. In fact, what we're talking about today with this conjunction just involves the inner portions of the solar system, just involves the sun and the Earth and Jupiter and Saturn. So I'm going to just show a picture of these right here. So here's as we zoom back into the inner portion of our solar system. And I want to talk about the orbits of the planets. You have the sun at the center of the solar system. And then you have the Earth. The Earth takes about 1 year to go around. It takes exactly 1 year to go around in its orbit. In fact, that's why we call it a year, is because the Earth takes exactly 1 year to go around. As you move further out in the solar system, the planets move slower, and the planets take longer to go around their circles. And that's for 2 different reasons. First reason is that they have longer to go, because you can see that red circle that Jupiter has to go on is a lot bigger than the circle that the Earth has to go on. The Earth is closer in, so it takes less time. Also, Jupiter's moving slower because Jupiter feels the effect of gravity from the sun less, and that makes it move slower. And so Jupiter's moving, takes longer to go around the sun. It takes 10 years to go around the sun because it has a bigger distance to go, and it has a longer, and it's moving more slowly. Saturn, as you go out to Saturn takes even longer, and that's because it has an even bigger distance than Jupiter and an even bigger distance than, is moving slower than Jupiter. Now, you can imagine that this is kind of like runners on a track. If you have a stadium and you have all the runners going around in a circle on the track, they're each in their orbits. And occasionally a runner is going to pass another runner. They're going to overtake it. And so this is maybe at a secondary school. If you're at a track, you're running, and sometimes you will overtake and pass another slower runner, or traffic. Someone will overtake another slower car. And that's what's happening in our solar system. In fact, you can see what I've drawn with this line is how the solar system is right now. Right now, if you're standing on the Earth and you look at Jupiter, Saturn is almost right next to it in the sky. In fact, it almost kind of appears behind it. It's actually a little bit to the side of it. But if you look at a different time, let's move here to a different time. You go fast forward a couple of months or a couple of years. On the second plot on the right, you can see Jupiter and Saturn are in different portions of the sky. And so usually Jupiter and Saturn will be in different places in the sky. And so you see Jupiter over here and you see Saturn over here. But in this particular time, at this conjunction, Jupiter is passing Saturn. And whenever it's passing Saturn from our viewpoint, it overlaps in the sky, or it comes very close to each other in the sky. And that's exactly what we mean by this conjunction. Now you might think that when it overtakes Saturn, it's going to pass exactly right in front of us. So Saturn disappears like this. Turns out that the orbits of the planets are slightly tilted, and so it doesn't exactly pass in front. It passes a little bit above or a little bit below, and so you can still see them both, but they approach very close to each other in the sky. Now you can imagine if you look at this at Saturn here, sometimes Saturn goes around and around and around, and so sometimes it's going to be very close to Jupiter, and sometimes it's going to be very far from Jupiter. Right now, as you can see on the plot on the left, it's very close to Jupiter, distance-wise, and sometimes it's very far. And this happens about every 20 years. So Saturn takes about 12 years to go, or Saturn takes about 30 years to go around the sun. Jupiter takes 12 years to go around the sun. So they pass each other about every 20 years. And so every 20 years, they become close to each other in the sky. And here's just a little plot that shows, like, in 1960, they were close to each other. And then in 1980, they were close to each other, and then far. And then in 2000, they were close to each other. And then in 2020, again, they were close to each other. And so this conjunction between them happens every 20 years. And this is just like clockwork, because every 20 years, Jupiter passes Saturn in its orbit. Now, what's going to happen this particular year is that there's a very close passing. Usually, when they pass each other in the sky, they're separated by about 1 degree. It turns out that because the tilt of the orbits is such that this particular time, they're going to pass each other within about 1/10 of a degree. Now, what I mean by a degree, that's the angle in the sky. And if you were to hold out your finger at arm's length like this, so you can all do this, you can all look at something distant and hold up your finger. That's about 1/2 a degree. In fact, 1/2 a degree is about the size of the full moon. So if you put your finger out, you can about cover the full moon. Maybe you need to use your thumb to cover the full moon, but you can cover most of the moon with your finger. With this particular event, it's going to be about 10 times smaller than that. So even if you hold out your pinky or the pinky of a child at arm's length, it's not going to be able to cover. You're going to be able to easily cover Jupiter and Saturn. They're going to be very, very close to each other in the sky. And that's what's happening during this conjunction. Now, this conjunction happens for there's just the night of December 21st that they are super close to each other. But as you can see, they're getting closer and closer and closer during the entire month of December. And then into January, they're going to be coming further and further apart. And so this means that if you don't see it on December 21st, that's okay. If it's cloudy and you have monsoons on December 21st, that's okay. You can just see it on December 20th or December 19th or December 22nd instead. It's still really, really nice to see Jupiter and Saturn in the sky. So every 20 years, Jupiter and Saturn pass each other in the sky. And this is because Jupiter's the faster of these planets, so it's passing Saturn. This is not just one day. It takes several weeks for Jupiter to pass Saturn. So this, you don't have to, you can look tonight, you can look tomorrow night, you can look in 2 weeks, and you will still see Jupiter and Saturn up there. The 21st, they will be closest, but there's still a lot to see on the other days. Now, you're not going to see an explosion. You're not going to see a crash or a flare or anything like that. What you are going to see is the planets, and they're going to look like bright stars, and they're going to be easy to see, and they'll be bright. We call this a great conjunction because it involves the 2 largest planets, just because Jupiter and Saturn are the 2 biggest, maybe greatest planets. But every other planet passes other planets too. I mean, Pluto is the smallest and the faintest of the planets, and it will occasionally be passed by Jupiter or will pass Uranus. Jupiter passed Pluto a couple of months ago. No one paid very much attention to that because Pluto passing Jupiter or Jupiter passing Pluto. Now, Pluto is very, very faint, so it's not something that you could see just with your naked eye, just by going out and looking without a telescope. So you wouldn't really notice it. What's special about this one is these planets are really, really bright. And so I used to live in Bombay, and even from my flat in Bombay, I could see very easily Mars, Jupiter, Saturn, the moon, of course, Venus, Mercury. And so you don't have to be in a dark sky. You can see these planets as long as it's not monsoon. You can see the planets from almost anywhere on Earth. The one place you cannot see them is from Antarctica, and that's because in Antarctica it's daytime right now, and it's going to be daytime in 12 hours, and that's because the whole season long it's daytime in Antarctica. That means the sun is in the sky, and it's not going to be dark enough to see the planets. So don't go to Antarctica to try to observe the conjunction. Now, sometimes if you're in India, or sometimes if you're in the States, then the conjunction is going to happen during the day as well, because just like the moon is up during the day half the time, during the night half the time, sometimes Jupiter and Saturn will be up during the daytime instead of the nighttime. So even though I said that this conjunction happens every 20 years, some of these times it's going to be during the daytime, and it's very hard to see. So I said the conjunction happens every 20 years. What's special about the 2021? What's special here is that rather than passing 1 degree from each other, they're going to pass about 10 times closer to each other. Jupiter and Saturn will nearly appear right next to each other in the sky. Now, there's still 500 million kilometers, 50 crore kilometers from each other, but they look right next to each other. The last time this happened was actually almost 400 years ago. This was in 1623 that they were this close. 400 years ago was a really long time ago. And the last time before that was in the Middle Ages in the year 1226. What was happening in 1623? 1623 was when the astronomer Galileo Galilei from Italy, and he had actually just used his telescope. This is a picture of a copy of his telescope. And he had used his telescope to he was the one who discovered Jupiter's moons. Jupiter has 4 bright moons, which are going around it. And he had discovered them using his telescope. He was the first person on Earth who had made observations of them. He also used his telescope to discover what turned out to be Saturn's rings. And there's some sketches that he and other astronomers at the time made of Saturn's rings. And so this is what was happening in 1623. His observations were actually in 1610. And then 13 years later, we had a very close great conjunction, 1/10 of a degree apart. But unfortunately, this one happened when Jupiter was, during that season, Jupiter was up during the daytime, and so perhaps no one on Earth even saw it. We don't know for sure, but Galileo did not write about seeing it. No other astronomers at the time, Huygens didn't write about seeing it. No other astronomers at the time wrote about seeing it. And so it's possible that no one ever even saw it in the year 1623. So if you see this conjunction, you are seeing something that no one else has seen since perhaps the year 1226, 800 years ago. So that was 800 years ago that we were last able to see this conjunction from Earth. 800 years later, what do we know? We know everything now. I mean, we know so much. I just want to tell you briefly about some of the things that NASA is doing to explore Jupiter and Saturn now. For instance, we have one of Saturn's moons. It's called Titan. And we actually have a drone. It's a quadcopter, or an octocopter, actually. It's a helicopter with 8 propellers that you have that we are building outside of Washington, D.C., and we're going to fly it to Saturn. Now, it has to fly on a rocket. You can't use the drone component of it to actually fly through space because there's no air in space, but it flies on a rocket, and then it launches out of there's a parachute that comes out, and then it parachutes down toward the surface of Titan. The rotors turn on, and then you have a landing on the surface of Titan. Titan is a really interesting moon, a really interesting satellite of Saturn, because it has sand dunes, it has oceans, it has lakes, it has lots of chemistry going on the surface. And this is a moon which Galileo probably knew about. It was certainly known very soon after that. But didn't know anything about it. But now we're right on the edge of sending a quadcopter to go to the surface and explore the surface as kind of as a robotic explorer for us on the surface of Titan. We also have the Cassini mission. The Cassini mission was a spacecraft built by NASA and built by the European Space Agency. It spent 12 years orbiting Saturn, exploring its rings, its moons, its magnetic field, and the environment all around Saturn. And we have under development at NASA, we have the Europa Clipper mission, which will launch in the 2020s. And it's going to be going to the moon called Europa. Europa is one of the largest moons of Jupiter. And it's possible that Europa has life or the precursors of life on it. We haven't detected life there, but we know that it has lots of liquid water. And we also know that on Earth, liquid water is where life originated. And so we are very interested in going there to see what sorts of chemistry might be there at Europa. So in terms of observing this conjunction, here's a little sketch that shows what Jupiter and Saturn are going to look like night after night. You can see that back in September, you could see the separation between Jupiter and Saturn, and they were getting closer and closer and closer. So this plot shows how they are in the sky over time, from one week and 1 month on to the next one. And they're getting closer and closer as Jupiter is passing Saturn in the sky, slowly passing, because it takes 10 years for Jupiter to do a whole lap around the sky. So it takes, you know, a portion of that, a season, for it to catch up with Saturn. You can see this, you want to go to a place where you can see to the west. You can see to the sunset. If you can see the sunset, then you can see Jupiter and Saturn. Go to a field, go to the top of a building, go somewhere where you can see to the sunset. Jupiter and Saturn will be bright. Go out about 1 hour, about 45 minutes or 1 hour after sunset, and look for something which is bright in the sky in the direction of the sunset. And that will be Jupiter. Jupiter will be up about, 30 degrees up in the sky. And then just above Jupiter, you'll see Saturn. Saturn it kind of looks like a snowman. Saturn is kind of the smaller head on top of Jupiter. It'll be a little bit above and a little bit to the left of it. And they will get closer and closer and closer until December 21st. And then after December 21st, they will start to move apart from each other. Now I want to show you some pictures that have been taken by people across the world. Here is in fact a picture that's taken by an Indian astrophotographer, Rakesh Rao from Goa. This is a picture, and this is exactly what you will see if you go outside. Here you have Jupiter so you have the water tower in the center, and then if you look to the right of it, you see Jupiter a little bit brighter, and then Saturn right above it on to the right of the tower. This is a picture which is taken by the NASA photographer, Bill Dunford. This is over a lake in the United States, and you can see you can see Jupiter glowing very brightly there, and you can see Saturn a little bit to the left and a little bit fainter there. This is a picture which I took over some of the buildings in Washington, D.C. And over a lake, and you can see again Jupiter in toward the top of the screen, and then Saturn to the left of that. This was about 2 weeks ago, so the separation is getting tighter and tighter every day. This is a photo that I took about 2 months ago, and so here the separation was quite a bit bigger, and you could see Jupiter and Saturn, and also to the far right there you can see the crescent moon in the sky as well. Mars was also up all summer. Mars was really, some of you may have seen Mars during the summer. It was very bright and very noticeable. In fact, it was even brighter than Jupiter. Usually Jupiter is the brightest planet because it's the biggest planet. Even though it's a little bit further away from the sun, it's the biggest planet, and so it's usually the brightest. Right now, for this season, Mars was the brightest because it was so close to us. Here's a picture which I took of it's the Washington Monument in Washington, D.C. And so it's a very tall obelisk-shaped building in Washington, D.C., along with the American flag there. And what's great here is that even though there's an American flag here, this is something which can be seen by everybody on Earth, except if you live in Antarctica. You can see this from every place on Earth, as long as it's not cloudy, as long as you go outside. And again, here you see Jupiter and Saturn. This is a great picture that's taken by Keith Gleason, an astronomer in the United States, in Colorado. And here you can see Jupiter's moons. You can see Jupiter at the bottom there. You can see Jupiter, and then you can see its moons, Io, Europa, Ganymede, and Callisto. And then at the top, you can see Saturn. Saturn's rings are a little bit hard to see there. You really need this is taken with a camera. You really need something more to see Saturn's moons, or to see Saturn's rings. If you do have there's a couple of ways you can take photos of this. First of all, if you just have your smartphone, you can take a picture of the conjunction, and I'll show you in the next couple of photos. I'll show you I have a picture that's taken with a smartphone. You can also, because with a smartphone, Jupiter and Saturn are very bright. Let me find that photo here just a second. Here's a picture that was taken with a smartphone, and you can see Jupiter and Saturn right there. I used the night mode on my iPhone here, and but the Android phones have a night mode also. And so what happens during the night mode is you can hold up the camera for about 10 seconds, and it will essentially take a long exposure. And even if you shake the camera around a little bit, that's okay. It will fix this camera shake so that the camera will not be moving, and it will be kind of like as if it was on a tripod. You can use a tripod if you have one, but if you use the night mode on your smartphone, that works pretty well too. You can zoom in to Jupiter and Saturn if you want to, although I kind of like taking a wide angle photo because you can see the separation between Jupiter and Saturn. Now, as you get closer and closer to the 21st, they're going to get closer and closer to each other, so you might have to zoom in a little bit to see them. But in the time before the 21st, I like to take photos at night and include some of the background, for instance, a building or a sign or some people or this sort of thing, just because it makes the photo more interesting. So you have Jupiter and Saturn above, and then you have something else in the foreground. In this case, this is my daughter. We were on the beach, and we were digging holes in the sand at nighttime. Now here's another picture which I took. You can see Saturn and Jupiter with its, here you can just see 3 of its moons. Now this picture was taken with a DSLR camera. So this is like a sample of a DSLR right here. And so this one is made by Nikon. And I have a 200mm lens on this camera right here. 200mm lens is it's a big zoom, but this is not as big as some of the professional cameras, but it is big enough to see the moons very well here. And you can actually see, if you really squint, you can see Saturn's rings in this picture, and just to the left of Saturn, you can actually see the moon called Titan, which is where the Dragonfly drone is flying to, or will be flying to when it launches. Now, if you don't have a DSLR, that's fine. If you have a pair of binoculars, or if you can borrow a pair of binoculars, you may be able to see, they may be very worthwhile to use. This is a pair of binoculars here. You can use, some are bigger, some are smaller, but any pair of binoculars will help you out. And you can just point your binoculars at Jupiter and Saturn, and depending on the magnification, you may be able to see some of Jupiter's moons. Jupiter's moons will appear just like they do in this photo here. You'll see a couple of dots. And what's interesting about the moons is they move around quickly enough so that you won't be able to see them move, but if you come back a couple of hours later or the next day, you'll be able to see their positions change in the sky. This is one more photo taken by the NASA photographer Bill Ingalls next to a sunset showing Jupiter and Saturn. Here's one more taken by Keith Gleason in the United States, again showing the moons of Jupiter and Saturn. And that is what I have. So that's the end of my presentation. I hope that you're all able to go out and see the sky, whether it's on the 21st or before or after. This is a fantastic time to go out. People have had a deep connection to the sky for thousands and thousands of years. There's lots of cultural and historical and religious importance to the sky for many, many years. And I hope that you will all have the chance to go out and be curious and explore as people have throughout history. Thank you so much.
Yeah. So thank you, Dr. Henry. So now we can start our interaction, and we have a few questions. We can discuss about these questions, and then you can answer. And after that, we will also try to take few questions from our YouTube's comment section, where our visitors are asking. And whoever was watching this live streaming, please post your questions in our YouTube comment box so that we can take a few in the end of the discussion. So since this was very interesting and the way you have presented is really phenomenal, what is the actual separation? What do you think the actual separation we are talking, after sunset, we will be not able to see for a longer time because these two objects also, they are going to set. But actual separation will take place in the very late night as per Indian time I'm talking about. So what is your view? What is the actual separation?
So the actual separation, so the time of the actual closest approach, I actually forget exactly what time it is, But to your eye, it's going to look the same, whether you see it on the 21st or whether you see it on the 22nd or the day before, the day after. It will look, essentially to your eye, it will look very much the same. And so roughly 1/10 of a degree on all those times. And going out there and seeing it change is the important thing.
Okay. So is there any significance to the fact that this is on the solstice, winter solstice?
Oh yeah, yeah. So this is a good point. This happens on December 21st. December 21st is the winter solstice. So when the Earth's in the northern hemisphere is the furthest away from the sun, pointed wise, and that's just a coincidence. So this is happening near the end of 2020, near some of the holidays. It's entirely a coincidence.
Okay. So how long have people been predicting conjunctions? As you have pointed in your lecture, was how long? Some are also quoting in international articles. It's almost since last 800 years. There are few references, but what is the authenticity and what is your views on it? How long have people been predicting conjunction?
Yes, some of the Greek astronomers even. There's a Greek astronomer named Ptolemy, and he was in the year about 100 years after the birth of Christ in 100 AD. And he was likely to be predicting conjunctions back then. So certainly Kepler in the 1600s was predicting, or 1500s to 1600s was predicting conjunctions as well. So these we have been predicting for many hundreds of years.
Okay. So do conjunctions happen between all of the planets or just these two? Because these are the few questions which we have prepared based on the queries which we have been observing on our research and interacting with the people. So these are the questions from the common concept from the people. So do these conjunctions happen between all the planets or just these two?
Yes. So, in fact, there are conjunctions and occultations between the planets. Sometimes one planet will pass in front of another planet. Sometimes one planet will pass in front of the sun. In fact, in the past decade or so, we saw Mercury pass in front of the sun. And we also saw Venus pass in front of the sun. And so that's been really exciting to see those. You don't see those every day. But when I was in India one time, I saw, I believe it was Venus passing in front of the sun. It's quite rare that happens.
Okay, is this related to the opposition of the Mars recently during summer of 2020?
So yes, so very much this is not related, but this is one great thing that has been in the sky this last summer is Mars being very close to us. And that's just because essentially we were passing Mars in its orbit, just like Jupiter's passing Saturn in its orbit. And whenever you're passing someone, like you're passing them on the running track, or two cars are passing each other, that means they're close in the sky. And so it's essentially the same physics that we were passing Mars, and that makes it big and bright in the sky.
Okay, very good for your fun, very interactive and very engaging answers. Is this related to the solar eclipse which just happened on 14th December, which was not visible from India,
yes.
No doubt, but I have put this question because it will also give us a new perspective. Yeah, what is your views?
Yeah, so there was a solar eclipse. It was visible from Africa and visible from South America. I was able to see it only virtually, and perhaps some of the other visitors were also seeing it virtually. And this is unrelated. It's just a coincidence. There's so much great happening in the sky, and so it's a great opportunity to go outside and look and see what's up.
Well, so what is the best way to see the conjunction? And I'm putting this question before you because, you know, it doesn't require a telescope, but without telescope or a pair of binoculars we cannot distinguish using our human eye or normal using our eyesight. So what is your answer to this very interesting one? What is the best way to see the conjunction?
So perhaps at the conjunction itself, I think you will still be able to distinguish it. It's 1/10 of 1 degree, and some people will not be able to distinguish it. But I think that many people still will be able to distinguish that. So it will be a good study of who has the best eyes. But I think that you will see it as 2 points of light, not just 1 point of light. So I encourage everyone to look at it.
Oh yeah. In the between, I should say thanks to all the viewers. Some of them have joined from globally. So thank you, Dr. Henry, for putting in your network as well. So now let's continue. When should I go out and see it if I miss the date? and which is quite possible in India, because weather, as you know, in astronomy, weather is really big enemy. We don't know when the clouds will come along the line of sight. So when should I go out and see it? What if I miss because of the weather? Then what should I do? I means our visitors, our interesting audience, whoever is going to watch.
Yes, it's okay if you miss the 21st. Just go out on the 22nd, go out on the 23rd, go out on the 24th, or go out on the 20th. There are lots of opportunities. The 21st is the closest, but what's really nice is going out several times and seeing them get closer and closer and closer to each other. So if you miss it, that's okay.
But you have also mentioned during your presentation, but I want to once again bring to the notice of our viewers, if you can answer, how often do these conjunctions happen?
So these conjunctions, a normal conjunction happens every 20 years between Jupiter and Saturn, or what we call the Great Conjunction between Jupiter and Saturn every 20 years. And then a conjunction which is super close like this, a tenth of a degree, might happen every couple hundred years. The last one was 400 years ago. The next one actually turns out will be in 60 years, in the year 2080. So some of you, I'm sure, will be able to see the one in 2080 as well. If it's cloudy all of December for you, then maybe you can wait until 2080 and see the one then.
But you said during your presentation that this conjunction is closest in the last 400 years, as we all are coming together for this same conclusion. What more can you say about the one 400 years ago? But you have mentioned some references about we don't know, there is no scientific published data or any references whether after inventing or using telescope first time someone has observed this event. So what is your view on this?
It's very likely that no one observed it from the Earth in 1623. It was very close to the sun, so the only people who would have seen it is people who were looking at the sun and for some reason stared very close to the sun and saw the planets there. So maybe people did. Maybe they saw it just after the sun set. It gets a little bit darker, and then the sun won't blind you if you look at it because it's below the horizon. And then maybe you can see the very close separation then. But it requires people really looking for it. So maybe they saw it, maybe not. We just won't know. But I know that we will be able to see it this time because the timing is very good. It happens during the evening, not during the daytime.
Okay. So do the planets ever pass directly in front of each other? Here they are doing close to 0.1 degree, or I should say around 6 minutes of an arc, but not directly passing in front, correct?
Yes, yes, correct. Now, sometimes Jupiter will pass, in fact, directly in front of the sun. Now, this is very, very rare. In fact, the first time this will happen is in, I think, about 5,000 years. So come back in about 5,000 years, and Jupiter will pass directly in front of Saturn. But that just requires aligning the orbits exactly, and so that doesn't happen every time that they're going to be aligned exactly like that. And but if they are, it's going to be quite a sight. So tune back in 5,000 years, and you will be able to see that.
Okay, very good. You are really giving response very promptly. That's very fantastic, and I'm hoping that our viewers will be enjoying this program. Very interactive and engaging. We will take few questions from our comment box as well. The very important, you have touched upon very briefly, but I want to once again bring this question before you. All of us very much curious to watch. We don't know weather. That's okay if weather is clear. So can we do astrophotography? Can we capture images? I'm talking about for the general masses, whoever is interested in capturing this event using a smartphone or a pair of binoculars or telescope or even DSLR camera. And you have also brought during the discussion your camera and yes, your love and affection with the photography. What is your view on this?
Yes, so I hope you will. Yes, use your smartphone, use your other camera if you have a compact camera or a DSLR or a smartphone or a film camera. You may try it with any of these. The objects are bright, so yes.
Okay, that's great. So now we will take few questions from our directly from our comment box, which were asked by our visitors. So one by one I'll try to bring, and I think we have almost 10 to 15 minutes. Is it okay for you, Dr. Henry, if you will continue for more?
Of course.
5 to 10 minutes, though it is very late,
Of course.
and
Yes, please
in your
do the
place
questions.
you must have crossed the midnight.
We have, but that's okay. I
really
enjoy talking with
we
with
are
your
really
sockets,
thankful on behalf of
and I enjoy
Regional
talking
Science
with
Center
the
Bhopal
phonetics.
for your really support. You are in the close to midnight you are doing the program. So now question. Yeah, one of our colleagues from our Regional Science Center and Planetarium Calicut, he has asked that Manas Bakshi, he has asked that, is there any record that conjunction data has been used in calculations of the orbits or the orbital velocities? Are these conjunctions astronomically important?
So there is no science that we are going to be observing during the conjunction itself, but we do monitor the positions of the planets. We do monitor the positions of the planets always, and so they're always used in our calculations, but they're not. We don't watch them differently during the conjunction than at other times.
Okay. So another question I'll take. Reena Saha. She is watching our program. Reena Saha has asked, at what time conjunction is going to take place? And that's very important. It depends on the latitude and your location, but you can also answer. At what time this conjunction will take place?
Just go out after sunset. Go out about 45 minutes after sunset on tonight. Go out tomorrow. Go out the next day. Go out the next day. Any day for the next 2 weeks. And just go out after sunset. It's not that precise, and look up. So look to the west after sunset, about 45 minutes after sunset, and look for the bright things that look like stars. It is very, very easy to see.
Yeah, with some ID, I don't know the exact name of the person or the individual, but his or her ID is poetrification. And he or she is asking, as both of the planets are coming close to each other, what gravitational effects can it make? For example, on the asteroid belt.
Right. Yes, okay, so let me clarify one thing here. That sometimes you might, if you're looking at the sun, you might see an airplane move in front of the sun. That's what's happening here. Is Jupiter is moving very near to Saturn, but it's not, but it only appears that way from our viewpoint because it's blocking it. But in space, the airplane is not near the sun. And so in space, Jupiter is not actually near Saturn. So there's actually no gravitational interaction between them. It's more like Jupiter is here and Saturn is way back here, and they're passing each other like this, but there's no gravitational interaction between them any more than normal. And so that's why their orbits will not change at all. There will be no interaction between them. It is only because of our viewpoint from Earth that they look lined up.
Your voice is not coming.
My voice is not coming. Can you
now
hear
it's
me?
coming. Now it's coming. Yeah, it's coming. Okay.
Okay.
Thank you. So I think our program is also being watched by some YouTubers. One of the, YouTubers are really taking lead in the YouTube world. So the Coding K, it looks like he or she is a YouTuber, and we have a question from the Coding K. Very informative session, but I have a question. As sir told that NASA is building a drone or a quadcopter to observe Titan, then how it is going to move around? My God. Go ahead.
Yes, so the quadcopter is named, or the octocopter actually, because it has 8 propellers, is named Dragonfly. Dragonfly will go in space on a rocket. So there's a traditional rocket which will take it in space to Titan. Now, when it is on Titan, Titan has an atmosphere. Titan has an atmosphere which is, Titan is the only moon in the solar system with a significant atmosphere. And it actually has a very thick atmosphere, which makes it a fantastic place to fly a drone. You could fly an airplane on Titan. You could fly a balloon on Titan. You can fly a parachute on Titan. It turns out that the best science that you can get right now is by flying an octocopter, like what we're doing. And so that's why you can fly this. Now, Titan is not the first place, actually, that NASA is going to fly a helicopter. NASA has a helicopter which is on its way to Mars right now. Now Mars is a real planet, but it has a very, very thin atmosphere. Titan is not a planet. Titan is just a moon, but it has a much, much thicker atmosphere than Mars, which has a really, really thin atmosphere. Mars's atmosphere is about 1,000 times thinner than the Earth's atmosphere. And so flying a helicopter on Mars is extremely difficult. In fact, the helicopter that they have on Mars, the blades for this helicopter, you can look it up. It's called you can just look it up for the Mars 2020 helicopter, and you can see pictures of it online. And the blades for it are about 1 meter across here or so, and the payload for it is a little bit bigger than a cell phone, but not very much bigger. It's a couple hundred grams of payload on this roughly meter-sized propeller blade, and that's because Mars does not has a very thin atmosphere, and so it requires a lot of power, a lot of thrust in order to lift on through that atmosphere. Titan, on the other hand, is cold, but it has a very, very thick atmosphere. So Titan is an excellent place to fly this aircraft that we are taking there.
Yeah. So we have one more question from Kovid Manil. He asked, has at any time a conjunction happened between more than two planets at the same time?
Oh, yes, there has, but it's very, very rare. Maybe a normal conjunction like this might happen every 20 years between Jupiter and Saturn, and maybe a conjunction with Mars might happen every, I don't know, I would make it up, but let's say every 10,000 years you might have Mars there as well. So Mars, Jupiter, and Saturn together. I don't know the actual number. I don't know if it's 10,000, but it's something like that.
Yeah. Now we have one more question from Manoj Mathur. Once again, this question is related with the earlier question also. I think he's asking once more, but does the gravitational force affect their orbits? And now I have also one more question. I want to also add this in the same query. There are confusions in the people, because when we are talking about the conjunction, so mostly we should not get confused. So please give more clarification. They are million miles apart, even radially from Earth, and also side by side, because this angular separation and actual kilometer difference both are completely not digestible concept for most of us and for jargon-free people. So what is your view on that?
Yes, exactly. So let me put up my slide here. I'm going to share my screen again. And here's my slide. Now what you see here is Jupiter passing Saturn, but I want to emphasize that the actual distance is 50 crore kilometers between Jupiter and Saturn. So they look like they're very close, but in reality they are not very close. In reality it is many, many, almost, many, many crore kilometers between them. And so the gravitational interaction between these two planets is very close to zero. It is only because of our vantage point that all these things lay on the line, but they're not near each other in space. So there's no gravitational interaction between them.
Oh yeah, thank you. So I think these are the questions which we have taken from our comment box of YouTube channel. And from our colleague Manaji, we have one more question. If you can answer, if permitting your time, can proximity of Jupiter change the orientation of Earth orbit? Is there any study on it? And it is a very relevant question as well from astronomical studies point of view. So what is your view on
this? So the answer here is that the orbits of all of the planets are very, very stable. They have been stable for billions of years. And in the early days of the solar system, 4 billion years ago, 4.5 billion years ago, the orbits of the planets were unstable. And sometimes, in fact, the orbit of Jupiter could influence the behavior of Earth, or of Jupiter and Saturn could interact, or Jupiter and Mars could interact. In fact, that's what the asteroid belt is from, is because the gravitational interactions between Jupiter and Mars. But now the solar system is very stable, and there is no significant gravitational interaction which will destabilize any of the planets on very soon. So that's the answer there.
Oh, great. And now we have one more clarification from one of our viewers, though she was using another nickname for her account. Now she has clarified that her name is Nandini Srivastav. She is 14 years old, and she is also having one more question. And the question is, it is said that apart from planets, their moons are more likely to sustain life. Why? I think she is referring Jupiter,
yes.
or definitely Saturn, because as we all know, for extraterrestrial life, one of the satellites of Jupiter, Europa, and in the same scenario, Titan. Both are very prime target for our extraterrestrial life studies in coming future. So yeah, what is your view on this?
Yes, very much so. The moons of Saturn and the moons of Jupiter are very nice places to search for life. Here again is Titan, and Titan has a thick atmosphere. It has liquids on its surface. Now it's very cold on Titan, and so it does not have water on its surface. Any water on its surface is frozen into what look like rocks. It's just ice, but ice which is very, very cold. There is liquid. Liquid is ethane or methane, which is CH3 or CH4. It is, the chemistry is very different than on the Earth, and so life from Earth would not survive on Titan because it's too frozen and there's not liquid water there. So maybe there's life on Titan, but if there is, it's very different life than what we know on Earth. Certainly what we can say and what we're interested in looking for is complex chemistry there. We know there's a lot of complex chemistry there because there's a thick atmosphere, and there's liquids, and there's ultraviolet light from the sun, and there's lots of physics and lots of processes and so forth going on there. So we're very interested there. Here's a picture of Europa going around Jupiter, and what we know here is that there's liquids there too. In this case, it's liquid water. And anytime there's liquid water, well, that means there's a heat source, which is making it warm. And this is kind of a protected environment because it's below the ice shell, sort of like below the North Polar ice shell on the Earth. And so we think this is a very interesting place that we don't know if there's life there. We certainly have never detected any life there, but we are interested in there. So these are all moons. Europa and Titan, also Enceladus, the moon of Saturn named Enceladus, also probably has liquid water below its surface as well. We're interested in it as well, and we don't have a mission which is going there right now. We did study it with a Cassini mission, and it just so happens that all these are somewhat warmer than the planets. We don't expect there's any life on Jupiter because Jupiter is has the gas at the outside is cold, and then it's very hot at the core, and there's fewer protected environments like the warm, wet environments that we know are on the satellites. So that's why we're interested in the satellites or the moons rather than Jupiter and Saturn themselves.
Yeah. Can you turn off your screen sharing? Yeah. Yep. So now one more question from Rina, then we will wrap up this program. Though I think she is a student, and that is why she is having more curiosity in size and shapes of the planets and satellites. So she is asking, is Titan larger than Earth?
Titan is about the same size as Earth. I actually forget whether it's slightly bigger or slightly larger. I will leave that to the student to.
Yeah, we can do it. We can do it. The size studies and comparative studies of the planet. Yeah.
You may use Wikipedia to look it up. But there is, what's interesting about Titan is there is so much physics there. All of the, so much of the physics and the geology and the processes which are happening on Earth, like sand dunes and like lakes and like rivers and like erosion and like impact craters and mountains and valleys, all of these things which are happening on Titan are like happening on Earth are also happening on Titan. So it's really one of the most interesting places in the entire solar system. And so go to the Wikipedia page about it, read about Titan, and welcome to explore that at length to see the physics that's going on there. And then please follow the Dragonfly mission. You can read about the Dragonfly mission from that webpage on Wikipedia as well.
Yeah. In the end, though we have a few more questions, but keeping in mind our time, and you are really doing great service to the science for supporting. Even the time is not a very appropriate. It's a post midnight at your place. On behalf of Regional Science Center, Dr. Henry, we are very much thankful to you, and I want to bring in your kind notice this program was streamed and still streaming on our YouTube channel. So all viewers and our esteemed visitors, we are requesting you to please subscribe our channel and also press the bell icon and also like our Facebook page so that we can bring more such updates about our upcoming events. And very important announcement, we have also organized live streaming of upcoming great conjunction if weather permits and other arrangements. So definitely on 21st December as per Indian Standard Time from 6 p.m. in the evening, we are going to stream this rare celestial drama, I should say, of these two gas giants, the biggest planets in our solar system, Jupiter, and next to Jupiter is Saturn, at 6 p.m. on 21st December in 20th December, that is on Monday. And we are also very much thankful to the viewers who have asked questions while interacting with Dr. Henry. And this program was also streamed on our National Council of Science Museum's Facebook page. So whoever have watched the program, we are very much thankful to everyone. And Dr. Henry, once again, thank you so much for your such a wonderful and very engaging talk.
Thank you so much, Saket. Thank you, everybody, for tuning in. Thank you, everybody who asked the excellent questions. And I wish all of you best of luck in viewing the conjunction tonight, tomorrow, and onward until the end of the year. And hope that you have clear skies, and thank you again.
Yeah, and one more thing I want to say before going, and since NASA's official live program is on 17th December, that means as per Indian time, Indian Standard Time, that would be night time. So NASA your headquarters is organizing some event. So what is the event you are going to talk about in that event?
Yes, that's right. Thank you for mentioning that, Saket. There will be a program called on NASA Science Live, and it will be at 3 p.m. Eastern Standard Time on the 17th. And so that's in about, 15 hours from now. 14.5 hours from now, I believe. And so for those of you who are in India, of course, it will be in the middle of the night. But if there's anybody else who may be in a time zone where they can watch this, or anybody in India who would like to watch it during the middle of the night, I encourage you to see it. I will be talking with some of the hosts of the NASA TV network, and we will be discussing the conjunction again, showing some of these photos, some other photos that have been contributed by viewers and fans of NASA from around the world, and we'll be talking again about how to observe it, how to photograph it, some of the history, and so forth. So it should be a really good show. But you've heard most of it here. So
that means we are the first. That means we are the first.
You are the first. So no need to watch the second show unless you really want to, and so.
Yeah, all the very best for your upcoming event and future endeavors. And whenever you have planned to visit India, please do visit to Regional Science Center Bhopal for the cause of science popularization. Thank you, Dr. Henry, one more time on behalf of our council and our science center and our entire team. Thank you.
नमस्कार साथियों, कंसेप्ट टॉक में आपका फिर से स्वागत है। आज की कंसेप्ट टॉक में हम डिस्कस करने वाले हैं कि जो फार्म बिल्स को लेकर या फार्म एक्ट्स को लेकर, कृषि कानूनों को लेकर जो विरोध इस समय दिख रहा है, हमें उम्मीद थी कि आजकल में चीजें ठीक होंगी, लेकिन होम मिनिस्टर के इंटरवेंशन के बाद भी चीजें भी ठीक होती हुई नजर आ नहीं रही हैं। और इतना कंफ्यूजन, इतने डिबेट्स हैं, किसी को लग रहा है कि किसानों को परेशान कर रहा है, कितनी बुरी बात है। किसी को लग रहा है कि जो लोग विरोध कर रहे हैं वो किसान हैं भी या नहीं, ये समझ में नहीं आ रहा है। कोई इस बात से परेशान है कि ये पूरे देश के लिए अगर एक्ट है तो फिर पंजाब हरियाणा से ही विरोध क्यों हो रहा है, बाकी राज्यों से क्यों नहीं हो रहा है। कोई कह रहा है कि सरकार ने जिस तरह से बिल पारित करवाए हैं, जो एक्ट बनवाए हैं, अनकॉन्स्टिट्यूशनल है। और सुप्रीम कोर्ट में जैसे ही इसको चैलेंज करेंगे वैसे ही खत्म हो जाएगा। कोई कह रहे कि 1991 में जो न्यू इकोनॉमिक पॉलिसी आई थी, इंडस्ट्रियल पॉलिसी आई थी, तो इंडस्ट्रीज के साथ जो